Okay, there was one important chart I didn't get to in that first part of section 4.1. So I just do want to go over that. This will cover several of the other discussion questions also. So to give a pictorial representation here of what different types of sampling methods would be like, picture each of these little dots as some kind of person or a unit in a population. And maybe we can think of it as a school or something like that. So if we have all the different students in the school and we take this simple random sample, if it looks like we're taking a sample of size 6, it really could be any 6 of these dots. We have no restrictions on which 6 are being chosen, and that's just determined by some random number generator usually, or drawing names out of a hat. In order to do this, one thing to notice is you do have to have an entire list of the population. Otherwise, you won't be able to randomly choose certain units from the population. And it's often not practical to have that entire list. But if you do, this is what a simple random sampling looks like. Now, stratified random, before we actually choose, we divide the population into groups. It does not have to be equal groups. In fact, it usually is not. So even though these bars are placed here, we could have instead a bar right here and a bar right here and have the entire middle be the central part. It doesn't have to be three components either. But once we get that, those strata determined, inside of each strata then we take a random sample. Now it also doesn't have to be the same number per strata. For example, if we have some kind of corporation and we want to stratify by gender, and we have 60% of the corporation is male, 40% is female, there's a couple different ways we do it. We may stratify into male and female, and then we may take whatever size. If we want to take a sample of size 100, we may make sure that 60 of them are male and 40 of them are female, so we represent the actual percentages in the population. Or we may decide to do half of our sample from each one, so 50 males, 50 females, even though there's 60% of the people at that corporation are males. So both of those are a type of stratified random sampling. The important part is we're dividing the sample into the population into strata and then taking a random sample inside each of those strata. Now with cluster sampling, we somehow block off the population into these clusters, but then we take a random sample of the clusters and anyone who's in the cluster gets chosen. It looks like a very non-representative way to do this, and it can be, the reason it would be used is for its practicality. So for example, if we were looking at some type of study on education, and we went into a school, well, first of all, we may decide which schools to look at, but within a given school, maybe we divide it into classrooms, homeroom classrooms, and then say, okay, we're going to take Miss Miller's homeroom, Mr. Johnson's homeroom, and Miss Patrick's homeroom. And then inside their homeroom, we'll take all the students, because that makes sense to go into a classroom, collect data on everyone. It'd be a lot harder, for example, to do a simple random sample where you're going to have to go into a classroom, hey, we need this student and this student. Now you go into another classroom, we need this one and this one. And you can also have a two-stage clustering. So this is what I almost said earlier. Say we have a district with 8 schools in it. Maybe we choose 3 of the schools, and then once we've chosen the schools, we choose 2 students per school. There's actually a large national database taken about every 10 years or so that does exactly this. They choose the school and then take a random sample within the school. And then the systematic idea. The systematic idea is with random start, so we're not automatically starting with the first person or with for example, we're taking every 10, we won't necessarily start with the 10th person and the 20th. So we get a random number between 1 and, in this case, 3, 4, 5, 6. So a random number between 1 and 6. That'll tell us where to get our first circle. And then after that, we take every sixth person or unit. So why isn't this the same as a random sample? I know this is one of your discussion questions. If the population is not distributed randomly to begin with, this will not give you a completely random sample from the population. For example, you might have some pattern that occurs every few people, and if it does, with a systematic sample, you're either more likely to get lots of people with that, whatever that pattern is, or you might happen to just bounce over the people that have the pattern. Another thing that might happen is, if we're looking at a phone book, for example, people with the same last name are more likely to be related, perhaps more likely to know each other. A systematic sample would almost, what would prevent the chance of getting someone who's nearby your name, whereas with a random sample, you could have 3 of the people with your last name, or it allows, a random sample allows you to break the patterns a bit more that could be underlying your population in a systematic sample.